All right, this is lesson 5.4, part A, lesson 5.4, day one. We'll be analyzing graphs of polynomial functions. All right, so let's just jump right in to example number one. Part A, it says graph each function by making a table of values. All right, so as you can see, this function, we have x to the fourth plus 2x to the third minus 5. We don't really know what that looks like. So when in doubt, plug in some numbers just to kind of get an idea of what this might look like. So I'm going to go ahead and let's plug in -3. Let's plug in -2, -1, 0, 1, and 2. All right, just to kind of get a good idea of what this graph will look like. All right, so when I plug in -3 into my function, there's different ways you can do this. You can use synthetic division, or you can literally just plug in to your function x to the fourth plus 2x to the third minus 5. All right, so when I plug in, I get -3 to the fourth plus 2 times -3 to the third minus 5. All right, and that gets me 81 positive plus 2 times -3 to the third. Now, -3 to the third is -27. All right, times 2 gets me -54 minus 5. All right, and then if I add that all together, that gets me positive 22. Okay, and then we would continue to do that, plug in -2, do the same thing. All right, and that would boil down to -5, plug in -1, etc., etc. All right, this would get me -6. 0, that's easy to plug in. We would get -5. 1, I would get -2. And 2, I get 27. All right, so by plugging those in, I would get those numbers for my table. All right, now let's go ahead and plug in what we can onto the graph. So 0, -5, 1, 2, 3, 4, 5, right here. -1, -6 is down here. -2, -5 is back up here. 1, -2 is right there. And -322 is way, way, way up here. So it would skyrocket here. And then connecting these dots at 2, it would go all the way up to 27. So it jumps way up here. So it'll look something like that. All right. Now that shouldn't surprise us because we know it is an even function. So the direction should be going the same in the end behavior, and the leading coefficient is positive, so they should both be going up. So that checks out. All right, and I made my graph. Okay, part B. So this was part A. Part B is asking us to determine the consecutive values of x between which each real zero is located. All right, so I know the real zeros are where it hits my x-axis. So I see 1, 2 real zeros, okay? And I see that 1 is going to be between when x is -2 and when x is -3. All right, so I'm going to say between -3 and -2. And the other one is between 1 and 2. So between +1 and +2. Another way you can see that with your chart is where it goes from a negative number to a positive number, right? or between a positive number and a negative number. All right, so we see that sign change. That's when it crosses the x-axis. So it's between 1 and 2 and between -2 and -3. And that's a way to look at the chart and find those consecutive values. All right, and then part C, to estimate the x-coordinates at which the relative maxima and minima occur. So relative maxima and minimum are basically where it changes from decreasing to increasing or increasing to decreasing, basically when you see like a hill or a valley, essentially. So this right here is a relative minima because that's where it's the lowest. All right, so I would say that there is a relative minima when x is -1 is where that is. So x is -1, and that is a minima. I'll just call that a min. All right, so a minimum. All right, so that is number 1. Okay, let me show you again with number 2. All right, so number 2, once again, I'm going to go ahead and plug in a few numbers just to get a good idea of what this graph might look like. I'll plug in -2, -1, 0, 1, 2, and 3. 0 is the easiest one to plug in, so you get +1. And when I plug in 1, I get 1 cubed minus 2 times 1 squared plus 1. And that gets me 0. All right. Plug in 2, I get 2 cubed minus 2 times 2 squared plus 1. So that's 8 minus 8 plus 1 gets me +1. All right, and then you just keep doing that with all the different points. I got 10 when I plugged in 3. I got -2 when I plugged in -1. And I get -15 when I plug in -2. All right, so let's plot these points. 0, 1 puts me here. 1, 0 is right there. 2, 1. 3, 10 goes out of my graph, and -1, -2. And -2, -15 goes all the way down here. So it looks like it's doing something like that. All right. So that is my graph. And again, it's odd degree, so it goes in opposite directions, and the leading coefficient is positive, so the end behavior checks out. Okay, part B, let's go ahead and see where the x-coordinates are for any real zeros. All right, so for any real zeros, it looks like we have 2 of them. Let me highlight that in red. So I got a real 0 here. All right, and that one is between -1 and 0. So between -1 and 0. All right. And then the other one is right at x is 1. All right, so I'll just say on x is 1 for that one. This one, where it hits the x-axis, right at x is 1. Okay, and those are the only 2 places this graph hits the x-axis. So those are my real zeros. Okay, and then part C, we want to find the relative max and mins. All right, so max and mins, let me do this in blue. I have a relative max right here where it peaks, and that is at x is 0. So x is 0, I have a relative max. And then at this point right here is also when there's a minimum, all right, a relative minimum. So that is x is 1. And that's where we get a relative minimum. All right, and that is example 2. Okay, let's go to the next one. Sorry, the formatting got a little funky. These are the directions for the next page. So it says sketch the graph of a polynomial function with the following characteristics. All right, so we want to make a graph given these things. All right, so number 3, we want to make a graph that's an even function with zeros at -2, 1, 3, and 5. All right, so we have -2 is a 0. So I'm going to go ahead and make sure my graph hits the x-axis at -2, at +1, at 3, and at 5. And for it to be an even function, I know the end behavior has to either both go up or both go down at the ends. All right, so go ahead and sketch your graph. Let's say I want to both go up. I can do that pretty easily and cross the x-axis at those points. All right, so that is a potential option. You could also make them all go down and do something like that, and that would work also. All right, so as long as it hits the x-axis at these points and their end directions are either both going up or both going down. All right, so that would be my final answer. Okay, number 4, a 5 degree with zeros at -4, -1, 3, and a maximum at -1. All right, so zeros at -4, -1, and 3. All right, and I should just specify just at those values and not more, and a relative maximum at x is equal to -1. All right, so since I want a relative maximum at x equal -1, I know that it needs to peak at that point. All right, and so let me go ahead and kind of hit that 0 right there on that side. And I need to hit the other one too. Now I can't just do this because that's an even degree, so that doesn't work. So I'm going to need to be a little creative and let me make a relative minimum and a maximum and go down to make sure that I have an odd degree function. All right, now I actually know this is going to be a 5 degree function because you can tell the degree of a function based off of how many turns it makes. So let me show you what I mean in yellow here. So if I follow the graph, I go 1, 2, 3, 4, 5. All right, so it goes up, down, up, down, up. So if you look at how many arrows I just made, 1, 2, 3, 4, 5, 2, 3, 4, 5, that actually should match your degree. All right, so that is my final answer. Okay, let's go to the last type of problem here. Okay, so it says complete each of the following, and we want to estimate the x-coordinate of every turning point and determine if those coordinates are relative maxima or relative minima. All right, so with graph number 5 here, I see I have a relative maxima, minima at this point right here. There, that's a minimum, that's a maximum, and that's a minimum. All right, so we're just estimating the coordinates here. So then I have x is -3 is a minimum relative. X is -1 is a max. And x is a little shy of 3. So I'll say 2.8 is a minimum. And we're just approximating. So if you put 2.9, 2.7, 2.6, any of that is fine. All right, the next one, we're going to estimate the zeros. All right, so remember, zeros are where it hits the x-axis. So I have one at -3, one at 0, and one at 4. So x is -3, 0, and 4. All right, part C, determine the smallest possible degree of the function, smallest possible degree. Now remember the arrows that I just showed you in example 4. I went down on this graph first, then up, then down, and then up. All right, so I got 1, 2, 3, 4 arrows. So that means I have a possible smallest degree of 4. All right, and the last thing is determine the domain and range. All right, so I'm going to scan across my x-axis, and I see I have graph going everywhere since the arrow goes to the left and the arrow goes to the right. So my domain is all real numbers. For my range, as I'm scanning along my y-axis, I see that I have graphs starting right at this point right here. That's the lowest point at about, -115. And then if I go up, I get graph everywhere else. So I have y is greater than or equal to negative approximately 115. If you put 119, 118, 17, 14, that's totally fine. We're approximating. All right. And let's try this last one, number 6. All right, so number 6, part A, estimate the relative maxima and minima. All right, so I see I have a max here, I have a min here, and I have a max here. All right, so x is -2, I see a max, relative max, I should specify. I have a relative minimum at x is -1. And then x is equal to, about 0.25. I have a max. All right, let's go to part B. And part B is saying estimate the x-coordinate at every 0, and that is where it hits the x-axis, so right there and right there. So approximately -2.2, I'll estimate, and -1.7. All right. So again, if those are off by a little bit and you don't get the exact same thing as me, no big deal. Should be approximate though. All right, part C, I have what is the smallest possible degree. So I look at how many directions it goes. So it goes up, and then it goes down, it goes back up, and then it goes down. So I got 1, 2, 3, 4 arrows. So smallest possible degree would be degree 4. All right, and lastly, domain and range. Domain, again, since they're both going left and right infinitely, I have all real numbers. And then for my range, I see if I scan along my y-axis, I have graph everywhere up until I hit the 2. All right, so I've graph all along here, and then I don't have any graph beyond y is 2. So y is less than or equal to 2 would be my final answer. All right, guys, that is lesson 5.4, part A.